So the offset and associated with the thumb instructions, the BLX and branch exchange instructions, we will deal with when we talk in thumb instruction set. So the next instruction set is load and store instruction, which is very important. Please understand. So load and store instructions, many questions will be asked usually. So what we will say, if I want to transfer data between memory and processor registers, you can call it as processor registers. So it means processor registers means I need to have an instruction. I need to have an instruction to move data from memory to registers. Please understand, registers are moving the data from register to memory. That's what. So as I said, in many of the earlier programming languages like 8085, 8086, 8186, all programming aspects involves the instructions which are memory related, so many. That's what, please understand one statement here. When the memory is involved with the registers, there are so many instructions to get the data from the memory to the register and register to the memory. But in case of ARM processor, you
Is
try
it
to
possible to increase the font, sir?
Oh, okay.
With
It's not
lowering the
audible
font.
clearly.
No, sir, the font of the text, sir.
Oh, okay.
Font
It's
size.
less, huh? Okay.
Yes, sir.
I'll just change it then. Wait. Okay. So I want to move the contents from memory. I want to move the contents from memory. So what I will do, I need to have an instruction from memory to register, register to memory. So usually earlier programming 8051 and 8085, memory is very much involved. That's what, there are so many instructions to move the contents from register to memory, memory to register. There are so many instructions. But in ARM processor, what happened? Most of the programming happens with the register. Data processing instructions. When I want to process the data, either arithmetic operations, compare operations, logical operations, branch operations, any multiply operations, anything, any sort of stuffs with respect to data processing, there is no much memory concept involved. Even with respect to the program status register instructions. So memory comes only when, if I wanted to fetch the instruction from the memory, that automatically happen. That is called execution process, fetch, decode, execution cycle, that will be taken care by the processor. And the next thing is, if I wanted to fetch the data from the memory, the data, 8-bit data, 16-bit data, 32-bit data, or I wanted to store the data from the register to memory, we'll go ahead with some instruction specified, which is called as load and store architecture in ARM processor. Load and store architecture itself, it is called. Load and store instructions are there, specific instructions, and they are for transferring the data between memory to processor register or register to processor memory. So it means that only two instructions are available. I'll name them as load register, LDR, load the register, load the register. Load the register from the memory. LDR is nothing but memory to register. Load the register from the memory. LDR is the instruction. STR, store the register. Store the register where? Store the contents of register onto the memory location. So there are memory location indications on which I need to store, or there are memory locations from where I should fetch the data and store it in the register. So it means that LDR and STR are the only two instructions which are associated with memory when storing the data or loading the data. So please remember, when an instruction is associated with a memory related operation, there comes the extra term called as addressing modes. Usually in earlier programming, instructions and addressing modes are taught together, one after the other. But here, addressing modes are very much associated with load store architecture only. That's what we haven't ate your head before dealing with the earlier instruction set. Okay, that's the idea you should keep in mind. Earlier instruction set doesn't have the concept of addressing modes. What is this addressing mode? Very interesting concept. It is associated with load and store instructions. Addressing mode is nothing but various ways of specifying the operand. It means any instruction, if I write LDR, MOV, move, okay, CMP, compare, MUL, multiply. If I write like this, those are called as mnemonics of the instruction, right? It is an instruction. That instruction, when I convert it into hex code, that or machine code, you can call it as machine code, that is represented as opcode. It is called as opcode. Move converted into binary form or hex form, it is called as opcode. MOV, LDR, STR, CMP, compare. So these things, if they are converted into a binary code, that is called as opcode. If any data associated with that instruction, for example, LDR hash 10, something like this, R1 comma hash 10, something like this, LDR R1 comma hash 10. There 10 is the data. That data is called as operand. It is not only the data, it may be address. 8000 is the address, or the address is present in a register. Register itself is called as having the data. Then that data is called as operand. That's what in all assembly language programming, 8085, 8051, or whatever you call now as ARM processor, all these things have the opcode and operand associated with an instruction. Operand means data on which we are going to operate. Opcode means that instruction in its hex code or binary code, you can call it as. Opcode and operand are there in an instruction. Now, what is addressing mode? Addressing mode is various ways of specifying the operand. Operand means data, I told. How I should place the data in the memory, how I should get the data from the memory to the register. This technique is called as addressing mode. Use different addressing mode to specify the data, whether it should be stored in the memory in a particular location or from the memory to a particular register. Various ways of specifying the operand is referred as addressing mode. So addressing modes are useful in this load and store instruction. Now let us understand what I said. I have what is that called as load store instructions. They are used for transferring the data between memory and register, or register to memory, memory to register. Memory means what type of memory you have: 8-bit memory, 16-bit memory, 32-bit memory. Here in ARM processor, 32-bit memory is there. Even in that, 8-bit data can be stored, 16-bit data can be stored, 32-bit data can be stored. So that is different issue. Now only the memory is there on which we need to assign the data from the register. That's what register to memory. Store instruction will use for that. If I want to fetch from the memory location to the register, I'll use load, LDR, load the register contents from the memory location. So memory will have the data in it. So now this memory is playing a very important role. That's what are the different types of load store instructions are there? What are the different types of load store instructions we have? So we have to study importantly for even uh, exam point of view also, single register, very important. Single, can call it a single register transfer instructions. What is that? Single register transfer instructions and multiple register transfer instructions. Multiple register transfer instructions. And we have swap instructions. We have clearly what is that called as swap instructions. Okay, swap instructions. So these are the instructions. Today, actually, I thought of to complete the single register. It just so happened that now, just a minute. Okay, so what is that we are writing now? So we will start with single register transfer instructions. Please understand the instructions and just try to practice accordingly. So I told you all the instructions should start with the pre-conditions and post-conditions with the clear examples. Please practice all accordingly with the textbook or various PDFs you can have, and just practice accordingly with the various examples by taking your own values. Now, so what is this single register instruction? Single register transfer instructions, right? So it is nothing but which is used, single register transfer instructions used for, what is that? Used for moving a single data item. You can say transferring or moving. Used for moving, please understand, single data item. I wanted to move a single data item in or out, in or out of a register. Please understand. What is the interesting point? I have a register with me, 32-bit registers, R1 to R15, special function registers are there, including all, total 16. And I have a few extra registers also, we'll make use of them. Used for these registers, I wanted to move the data into this register or from this register, from a single data in register, one single data. So that such kind of instructions are referred as single register transfer instructions. Single register transfer instructions. Okay. Now in this, what kind of data you are talking about? The data types what you are using. Please understand and remember the data types supported here. The data types supported are, you need to write both signed. You know, when I represent a bit with the MSB bit as 1, it will be a signed representation. Okay, both signed and unsigned. How to represent both signed and unsigned, I clearly mentioned with example. Word, unsigned words, both signed and unsigned words, how many bits? Each are of 32 bits. Okay, so data types supported by this particular transfer instructions are single register transfer instruction, which is nothing but load store instruction type, are signed and unsigned words, and then there might be half words. What is that called? There might be half words. Half words. Okay, half words. It means 16 bits. So half words you can call it as. So what is that? 16 bits. 16 bits size, and even I can have bytes. Bytes means 8 bits. So 8 bits, right? 16 bits, 32 bits are supported by this particular type of instructions. Now, if I ask you, can you mention some load and store single register transfer instruction? Can you give some examples? Examples of what is that called as? Because they are associated with load and store. As I said, loading and storing the contents of the register onto the memory or memory to the register. That's what load and store. Single register transfer instructions, single register transfer instructions, which are, let's call it as LDR. So LDR, as I mentioned, or STR, LDR or STR. So which is associated with a condition followed by a destination register with address. You can say addressing, address or addressing. You can just name it like this. I can have LDR. There might be some other terms I can add. LDR. Okay, I can put a condition. I can have short byte. I can have hex. Okay, I can have short hex. Let us not worry about this. We'll come back. RD. Okay, then addressing. Another way of representing it. I can have half word. Okay, short of that. Okay, I can have byte, different data types you can say I can represent. Similarly, I can have with respect to str, I can have only half word. I can have I should not put my byte notation among addressing. So means from LDR, RD comma addressing means address take the value from the that's simple concept. LDR means load the RD register with address. STR means load the RD onto that particular address. That's the simple meaning. Now, how to represent? How to represent a simple words? What is this BH I just mentioned? BH I just mentioned. We can have the separate name for that. For example, simple LDR is there. I didn't mention the BH along with. So then I'll call it as load word into a register. What is the meaning? Load the word into a register. That's the meaning. Load the word into a register. How do you do that? You say that RD is there. RD is the destination register. For this, I will load. What is that? From this side. This arrow key. I'm showing that. Arrow key. I'm showing that I am just loading the contents of the memory. How I'll show the memory location? 32. I wanted to give the size of the memory. I'll call a mem as the memory. 32-bit says that it is 32-bit size. And what is that? It has address. Please understand like this. So similarly, I will say that str is the instruction. Str is the instruction. It says that save the word, save or store, whatever it is, store or save. Any word can be used. Save or store byte. B means byte or word. Usually word will take word from a register. From a register, it means from a register to where? From a register to memory. Please understand. Okay, so we cannot jump simply directly there. We can just have to have a clear picture of understanding. How I am doing direction, I should change now. RD to memory, I should show the direction. So memory, I'll write same. Mem is my indication to the memory of which address. Memory with the particular address location. Address. That is how we should write. So just understanding. Now if I write LDR is an instruction, load the contents of the register to memory. If I say LDRB, okay, so what is the meaning? Load the byte it is. Okay, it is loading. You can say load the byte. That's it. I'll write load the byte. It means earlier word into a register, now load the byte. Remaining things you understand. Load the byte into a register. That is what the LDR. So how it is done? RD. Okay, same way. RD arrow key on the byte, load the register, and which memory byte we said. That's what mem of 8 I will write. 8 means it's a 8-bit memory location. So address, some from some address, I will load the contents onto the RD. So RD will have that. Similarly, strb, so it means it is store the bytes, byte store the byte onto the memory. Please, store means onto the memory, load means onto the register. Memory to register is load, register to memory is store. So again same way, RD I should write, show the direction in the opposite way. I mean I am placing the content onto the memory. Which memory? Memory of 8-bit size. That's it. So that is the practice. So strb. Then if I say LDRH, okay. So when I say LDRH, what you will understand? Load the half word. Half word means what? Half word. These are the terms we should know. The same way you write, what is that called as RD? What is that? Half word means? Half word means it is memory of 16-bit. It can handle 16-bit data. So 16-bit size, data of 16-bit, 8-bit size memory, 16-bit size memory, 32-bit size memory. So likewise. So similarly, I can have strh. Okay. So like this, you please understand. So this is the simple practice. Store half word. Use the word half word. Half word is for storing the 16-bit data now. From RD to where I'll store? To the memory location. Which memory location? Memory location of capacity 16. 16-bit memory location, 8-bit memory location, 32-bit memory location. It's bifurcate the memory locations, 8-bit memory location, 16-bit memory location. Similarly, if I write, there is a small, right? If I write, what is the LDRSB is also there. What is LDRSB? LDRSB means load. Load the signed. That's it. Signed. So signed representation will be taken care by sign extend block, but it comes out as a signed number. When it comes out as a signed number, load instruction has to do that. Load SB, B capital here, load signed byte. Load signed byte is there. Similarly, I can have store, then I can have load signed half word. So like this you can represent. Please remember, you just have to remember in such a way that load LDR and SDR are the two most important instructions of load and store. So they also load the data on the boundary alignment. Boundary alignment, there is an alignment. What is that called? Alignment means boundary alignment. Boundary alignment means, you just remember, they follow the boundary alignment. Boundary alignment refers to LDR can only load 32-bit words on the memory address. That is, it means it can load the multiples of 4 bytes. So it can load 0 byte, it can load 4 bytes, it can load 8 bytes, it can load 16 bytes, and so on, right? Not 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 anything in between. Okay, please understand. So that is the boundary alignment. Okay, now if I ask you a simple question, if I'll write an example, what is that example? Let it go up. If I write an example stating that if if I just say LDR R not R, I write like this, we will understand by this. If the first question is asked, load the memory address contained in the register R1. Please understand, load LDR always refers to memory address. But where is the memory address here? I have written in the instruction always R0 refers to destination register. R0 followed by memory address should be there. This represents memory address. Load the memory address contained in the register R1. Okay, contained in the register R1. That is what you are passing. That's the simple meaning. What is the instruction says that load the contents. What is that? You can say load from memory address. Which memory address? Memory address contained. Memory address contained in R1. Please understand, R1 register. Contained in R1 register. Load from memory address. Memory address is present in R1 register. Go to that address which is stored in R1 register. That address will having some data. That data should be stored where? Store that data onto R0. Okay, in the register, and get the data, load from memory address contained in the register R1 register to the register R0, you can say, to the register R0. Here he hasn't mentioned the word data. You should clearly understand that the data is present in memory address. Now the memory address is present in register R1. So point to that address, go to that address, get the data from that address and place it in register R0. That's the loading the register R0 with the contents of the register R1. The contents of the register R1 is nothing but address of the memory location. Take the data from the memory location address and store it in R0. That is the meaning. Similarly, if you write R0 comma R0 comma R1, if I write, just in a reverse way of thinking. What is that? I should write it as store the content. What I should write it as? Store the content. Store the content contents of register are not. Register are not. 2. The memory location. What is the memory location? 8-bit memory location, 16-bit memory location, 32-bit memory location. Where it is? It is stored in the register R1, he is telling. So store the contents of register R1 to the memory address, okay, pointed by whom? To the memory address pointed by register R1. Please understand. That's the simple way. So this is called as a simple way of realizing the LDR and STR. What this type of assignment is called as, why I immediately write this example R0 comma inside bracket R1. Why not data first? So any way of writing this load and store instruction is basically divided into 3 types. That type is called as pre-indexed write back, pre-indexed and post-indexed. 3 types: pre-index write back, pre-indexed, then post-indexed, or you can use the word indexing. Pre-indexing with write back, pre-indexing only, that is second one. Third one is post-indexing. So indexing plays a very important role. Here, how to locate the location? I have two things. One is called as the base address, another is called as offset address. A register, whatever the data it has is the address. In this example, R1 has an address. That address is the memory location address. That address is referred to as the base address. For that, any offset can be added. Offset means any decimal value. If I add, for example, one address in R1 is 9000. If I add 4 to it, it will become 9004. So 4 is called as offset. So I am adding 4 to the base address, it becomes 9004. 9000 is the basic address, that is base address, plus 4 if I add, it becomes offset address. Now base address plus offset address comes together. So if I don't have offset, means offset is taken as #0. #0 means no address, no offset address. Base address is there. So base address always is there. So please remember, the offset from the register R1 in this example is 0. R1 is there here, no offset is there. So it means R1 has what is the idea called as base address plus offset address. Offset address. Okay. In this case, you just understand, in this case, offset is 0. You can say offset is 0. That's it. So now what type of this instruction is called as? That we will come to know in the next class. I'll clearly explain pre-index with write back, pre-indexing and post-index. These are the 3 types of instructions in load and store, which will cover the entire scenarios in the single transfer instruction set of the load and store. That practice we will do, and few examples on multiple load and store, so that that covers the complete load and store architecture. So please remember, the register R1 here is called as base address register. Okay, the register R1 in the above example what I mentioned is named as base address register. Just remember this. It means that I can point to an address by referring to the content present in that address. In that way we can go. So I'll stop here. We'll see the remaining things in the next class.